Hello friends, now we are going to discuss the second part of our project which deals with the face detection. First I will show you the working. As you saw friends, the code has been linked with my mobile and I was able to capture images from my mobile, and you saw the frames that were captured were stored over here, and finally the faces that were extracted, the face that have been cropped have been stored in this folder. I apologize for the poor quality of the images as my mobile doesn't have a good camera, but as you can see the face and the orientations have been cropped. If we want to link a better quality phone, a better with a better quality camera, we are going to have much better quality of images. And I have the option of resizing as well. Here I've written a code. If I run the code, I can, like you can see, all the images have been resized due to on standard. With the width is 300, the standard width. The width here is 300. As you can specify, you can give your own width as and how much the depends on the size of the image that you require. I'm going to explain both the codes to you how they work. Basically it's the camera, what the mobile camera does, it provides fluidity to our project, that if the teacher needs to take the images of the class, then he can have any student link his camera to the project and the corresponding images can be taken. Otherwise what we are hoping to do is to link this project with the Raspberry Pi and link the Raspberry Pi to a CCTV connected in the classroom so that we can capture all the images. The problem was our college was not having classroom with CCTVs. So right now to show you, I linked it with the mobile camera. First of all, let's now look at the code. This is the main code uh, on the basis of which everything is functioning. We import all the required packages, the imutils which is for video processing, the urllib which is for linking the mobile, the numpy library for the arrays, the imutils again the video, time is for the time lapse, cv2 again image to computer, os is as you know system, and the python imaging library which is for resizing if we need it. If we need it for resize, like I have written a separate code for resizing, you can include it here as well. So these are the libraries which we need. And first net is equal to cv2 .dnl. I'm sorry for the interruption. Net equal to cv2.dnl, read from cafe. Like here is as the line suggests, we load our model, and we load the model and the weights file which have already been stored. As I told you in the previous video, we're using the predefined weights which takes a variety of features into account, such as the distance between the eyes, the width of the nose, the width of the lips, how long is the face, and it tries to distinguish the face from the rest of the background. Now as you can see, the comment section is the video stream which has been initialized in the what this code does, it helps you to capture images through the webcam of your laptop. Right now we won't be leading we won't be needing it because we have linked our mobile camera with the project, so we are taking images through the mobile camera. We don't need to link it with the webcam, but if needed we can do it with the webcam also. That's why you can see the video stream src0, it's used for starting the video stream, and after 2 seconds each frame would be taken. Now as you can see is we take this URL. This is the loop over the frame from which the video stream is taken. Basically what we have done, we have linked our mobile through this to this video through this URL. Basically this is the URL. Basically what our mobile whatever images a mobile is capturing through IP webcam, the app which is called IP webcam, those images are being projected at this IP, and our system is able to access the video from from this IP, and thus extract the frame. Thus it is able to extract the frames out of out of that video. We need both our mobile and our laptop to be on the same network, so that the images, the video can be read and the images be extracted. Now what we do here, as you can see, we are resizing the frame. Basically that's why we import, we had the my width as 400 and PIL import image. As you can see, matlab from the Python imaging library we have imported the image, and we can set any width if we want, and we can resize it separately as well if you don't want to resize it here. I have done so. What it done is the image res is URL left dot require URL open. We have given this URL, and this URL will be open. The images will be read and converted into the byte array, as you can see, and the images would be decoded and the frame would be resized. And we can give the, as you can see, the read and sleep options as well to capture frames after a particular interval. That we can do, but here we actually don't need, we can give any interval. Here I have not given any interval because we are capturing it through the mobile, so only the interested part where we want to capture. We can give any sort of delay out of after which the frames can be captured. Here the logic is that the moment the frame is captured and the person is detected and his image is matched and attendance is marked, we won't need any more images of that person, so we can terminate a program accordingly. That will happen at a later stage. If we want right now, we can use this utility of using the interval and taking the frames. Here for the sample I have not taken it. Later on we can, obviously. And finally, we what we do now, the important part of the project start, that is the prediction, the how it is able to detect the entire the area on which the face is present out of the entire area. And naturally a DNN comes into play, the neural net that we that we the basically what we doing is the h comma w frame dot shape, basically the height and width of the frame, the frame which we have captured is taken in h and w. And what this neural net takes as an input is a blob like you see the color, as I might show you. uh, uh, Sorry, it's not present. Like here, the blob, what a neural net is doing, it takes the entire image as a blob, or a very large part of the image as a blob, and then it narrows down its search to finally the part where the face is present. The face is present in this part, so the blob would be the blob that which was taken as an input. It passes through layers and layers of neural net, and finally it is able to detect the presence of the face. As you can see here, there can be multiple faces as well, so we are looping over the detections. What in every loop what it does is, it the entire image first is taken as a blob. This box first surrounds the entire image, and then with each subsequent iteration the box keeps on decreasing and it zeroes in on the face. If we have 2 to 3 faces, or we can have many faces, we will see a blob on every face as it loops over the detections, because it's as you will see in the code. So the face, it has blob from image, we have resized it according to the frame, and we give this blob as the input, and we give the endpoints as well. And now if we say net dot set input blob, these are the defined values. As you can see, we don't need to actually reset them. It is basically from where the blob will start. We put the blob in the frame, the entire grab the frame dimension and we converted it to a blob. Basically whatever the frame would be, we are using, first we resize it to 300 comma 300. We can do it with any possible dimension, and then we put the blob of that dimensions. Basically, as I said, the entire image would be first converted as a blob. First, the entire image would be the boundary of the blob. Now, as pass the blob network update detections, as it says, we pass the blob through the subsequent layers of the neural net, and we obtain the detections and the predictions. As the blob passes through the layers, the search narrow downs and it finally zeroes in on the face. So as we say, net dot set input blob, the input is taken as a blob, which was the entire size of the frame, and detection is equal to net dot forward. We move the net forward with layer as it passes, layer by layer, as the whatever the detections would be, whatever would be the neural net which, as you can say, as I said, which trained on many features of the face. As and when the match would be found, there would be a detection, and the blob would be narrowing down to that particular uh, area of where the face is. Like I said, the what the blob will do, it will return the form of the height starting and the ending point of the blob, and the height and width of the blob. Those are the four values that are going to return. As you can see, start x, start y, end x, end y. So these are the four values that would be returning, and so that we will know, okay, these are the coordinates of which a match has been found. So now we loop over the detections. As you can see, can be multiple detections as well. For I in range 0 to shape I in range 0 to shape for I, like we say that if I is in range from 0 to shape detections dot shape to basically detections dot shape to, it's the height and width of those detections. The, as I said, the return is the height and width. So basically we have to see, we have to run it basically what we are doing over here is that the detection, that the loop is running over this part. That's the looping of the detection. Whatever the detections that we have got, we want to loop over that, and we said that extract the corner probability associated with the prediction. As I said, the neural net will be returning the confidence value as well, the detection value whatever it has detected, and the confidence value. The confidence value is basically the value with the probability. As you can see over here, the probability, if I zoom in, the probability with which the face has been detected, it's a side face or a front face, it's the probability. It's the 00I2 means the third basically the third function, the third the net, we say net dot forward, the third argument will return us the confidence value of a neural net. As you can see, there are two dimensions, and we have to pass the and we obtain the confidence in the third dimension, in the third argument. If, as you say, the confidence is less than 0.5, continue. You can have it as anyway. You can put it in the if condition. If confidence is greater than 5, we continue. If confidence greater than this 5, we continue with the, if greater than 0.5, we continue with the rest of the code. And if it's less than 0.5, continue means we again start over the loop again in the next detection. So again we loop over the next detection, the height and width over basically the detections dot shape 2. Basically it will say, okay, so whatever the basically the height and width, we will loop over this, and then the compute the bounding box xy coordinates of the for the object. Box equal to detection 00I3 into num array height width and start x equal to boss s star. What these three lines are doing, basically, as we know, the prediction has been made, the start x and start y have been written. We finally the input, the outputs, the basically the arguments that have been returned by the our neural net detections. We use 003 is to 7. These are the arguments that have been returned by the neural net into numpy array with the width and the height, because we want to compute the extra coordinate of the blocks, it returning in the form of the ratio. So into those ratio we scale down the image, and suppose this is the part of the image, basically the entire width and height is there. What part of the image, what part of the basically the image is our interested area, which is written, and we multiply with the height and the height to finally obtain the start and the end. We assume that the start and the end is there, the detections, the shape, the head and width, the height and width of whatever the detections are basically detected by our neural net. For over that we call the two dimensions that we said, height and width, and finally the area that has been returned, we multiply it with the width and height to finally obtain the start x, start y, end x, and end y. The coordinates finally, as you said, it was into the zero, the starting coordinates and the ending coordinates, the start x and end x, and start y and end y. We know, okay, this is the vertical and this is my horizontal line, and we can draw a box now. We're in a position to draw a box. As you can see, we can crop the image and we can resize the image, and finally we can store the image as I've shown over here, and the count is incremented, as you saw. Uh, Here, this is the two counts that we keep over here. One is for the video, one is for, as you can see, one is for this folder, the all the frames that have been extracted, and one is for this folder, which deals with only the faces. Suppose we don't have a frame with a face in it, so that count would be skipped. As you said, as I told you, that it can loop over multiple detections. Whatever detections we have, it will range whatever detections from zero detections or shape to whatever the detections have been, how many have been detected, all it's stored in this variable. And we are looping all over it. We are going to start it, the confidence basically it's returned 00 I2, and finally the detection 00 I, it's the possible row, and it's the second, basically the second argument, as I told you. And the box equal to detection 00 I 3 is to 7. As we start basically the neural net returns the start, and the I is the one, by start I means from start, it says the ith, basically what detection we are looping, and finally the 3 is to 7 arguments into height with the area that has been returned, and we multiply it and we get the final area. The start x, start y, end x, end y. Suppose this is my concerned area, the concerned ratio. I'm multiplying by height and width. I scale it down to get a box. I get a start x, start y, end x, and end y. Basically, my two horizontal and vertical lines over which my rectangle, the box would be drawn. Uh, the As you can see now, we the confidence for less than 0.5, we can reject the detection, or if we can change this number accordingly, 0 0.5, 0 0.6, zero point 0.4, totally according to us. If we want to continue, basically it's about the probability should be greater than 50%, only then we shall continue. If the neural net returns greater than 50%, only then we are going to continue the only then we will continue rest of the program. And finally we write it, and this is putting the text over here. Basically the value that we want to put over here, like I said, this font. So this code deals with a, basically the confidence into 100 is our probability, and rectangle the frame, and we give the coordinates starting to the ending, and we scale it down to the frame, and then we put text and we put font, and we this are these arguments, how thick should the font be, and rest of the properties of the font are covered in this snippet of the code. And finally we write a code. As I said, count and count when two variables are kept, and we press q for quit, and then we can quit the code, and this is how we will detect the faces. And now these will be the faces will be put into the final neural net. As I can show you here, this is my neural net, which is now my ready for training. I will gonna put them into the neural net and train my image. Like you see some comment entry, as we have decided. You have seen you see some comment entries because we have not we were testing the model. In the next video, I will this part of the project still in development. In the next video, I shall doing the recognition part, that is training the model, and finally trying to recognize who person is, who that particular person is whose image we are feeding. As you can see, the model, and we return the model, the ResNet model that we use. And you can see the model dot fit, the model dot evaluate, the epochs and the batch size we can give. And use one hot encoding. We can use other other possible algorithms as well. We shall see. This part of the still in development. We're trying to figure out which is the most accurate algorithm for our project. Right now we wanna focus on the ResNet neural net. And so this was all about the detection part. Now that we have extract the faces, and we have to put that as input into our neural net, and try to find out who that face belongs to. So in the end, this is the most critical part of the code. If you want to repeat, we are detections.shape2, we will are going to loop over the detections, the number of faces that have been depicted, the confidence of the ith detection. The second part of the argument is going to be put into the confidence. If it is less than 0 0.5, that means we don't go further, we continue. That means we start the loop over from the starting again with the next detection. Again, this is the box. As I told you, the 3 is to 7, the four arguments which return us the area which is we are concerned, the area where the face has been detected. This is how the output of the neural net has been in the confidence and the area with and into numpy array ws. Finally we multiply with the height and width to finally get the start x start y end x end y. As I told you, the start x and the start x start y, end x and end y, the lines over which we draw the rectangle. And this is how the rectangle has been drawn. The face has been detected and it can be cropped and the text can be put and the rest of it can be figured out. So this was the most critical part of our project, that is we have been able to detect the faces, and now we shall train our model based on the faces detected. I again apologize for the quality of the images. We can use Raspberry Pi to link a CCTV, or we can use a good quality camera. While we train the images, we are going to use the data sets that have been used. As I show you, they have been shot with a high quality camera, so there is no problem with the data set. The images which we will use for capturing the camera that will be used that we will use for capturing the image of the class is going to be a high quality camera. So we have to ensure there is a high quality camera so that the images captured are of good quality and accurate prediction can be made. So right now, for showing you, I had to use the camera of my mobile, which is not so good, so apologies for that, and thank you for your time and have a nice day.